Hello, hello, hello. Welcome to week 3 of social distancing. Squirrel and I have been doing very well. Um, I went outside yesterday. That was terrifying. Um, Squirrel made me wash my hands when I came back in. But I hadn't gone outside for over a week, so I figured it was about time. Let's take a look at our mission for this week. See what we're going to do. All right, so now that we've got our normal chart, let's talk about our classes. Today I want to talk about the practice number 2. And of course, today ends your little quiz from Friday. Many of you have already taken the quiz and done fairly well. If you did not do well and you would like a redo, just message me and I can erase your score and you can redo it. If you need help with it, reach out to me and message me. If for some reason the deadline passes and you need it reopened, I can reopen it. However, I will be quite distressed and quite disappointed in you. So that's what's happening on Monday. Tuesday, we're going to talk more about parallel proofs, parallel lines, and the proofs that we do with them. And we're going to actually start working backwards. So it's going to give us some givens, and we're going to have to work backwards to prove lines are parallel. So sometimes we are given that there are parallel lines, and sometimes we need to prove that the lines are parallel. So we're going to do some in-depth view on parallel lines on Tuesday. On Wednesday, we are going to be dealing with quadrilateral proofs again. Several of you are still struggling with those quadrilateral proofs. We're going to talk about them a little bit when we do practice number 2 today. But quadrilateral proofs are very big, very important, and they can go backwards as well. So we're going to take a look at quadrilateral proofs. And then Thursday, we're going to take a look at angle proofs. Now these have very little rhyme, very little reason. Some of it's just make it up as you go along. So that should be fun for some of you. Because good news, you don't have to memorize the reasons and all that stuff. Bad news is you're going to have to know a lot about angles. So it's going to be a big throwback to Unit 3 when we did that beautiful maze. Good stuff. And then Friday, of course, we will be ending with practice number 3. And then what's going to happen is you're going to take practice number 1, practice number 2, and practice number 3. You're going to put them together in a nice, neat little packet, and that is what we're going to judge your whole proofs-based lessons on. For labs this week, I'm sending something, hopefully tomorrow or today, depending on when the bus run goes. And it will determine whether you get it or not, will determine what we're going to do with labs for the rest of the week. There is a packet coming out. It's review for the regents that we really need to start taking a look at, because after this unit, we only have 2 more units before regents review. So we're going to need to start looking at regents and what regents looks like a lot and more in depth. So stay tuned. Tomorrow I will definitely talk more about those labs and what I want you to do for review and for practice. And that being said, let's take a look at advanced proofs 2. which is today's. They're on Monday. Today is practice number 2. Now, practice number 2, we have the linear pairs down here, the adding sides, all that good stuff. Here we've got diameters, or tangents and radiuses. That's all from the beginning of the unit, and I want you to try and do that by yourself as much as possible. If you need help, if you're struggling, definitely ask me. I want to pay attention more to the back. The back was the new stuff and the stuff that people are struggling with. So let's take a look at what's happening over here. So we do our statement reason for number 4, and of course A, B, C, D is a parallelogram. And if you notice, I am abbreviating parallelogram by just para. That is perfectly all right for the Regents. Okay, parallelograms. As I said, there are a whole bunch of different things that we can talk about with parallelograms. We can talk about parallel sides, and then that would make these alternate interior angles. We can talk about opposite angles being congruent. But my favorite part about parallelograms is that second one, where it says 2 pairs of opposite sides are congruent in a parallelogram. So parallelogram, 2 pairs of opposite sides are congruent. That means AD is congruent to BC. It also means that AB is congruent to DC. At which point, all I need then is my beautiful reflexive side, so DB equals DB by reflexive, and then we're done. We've got triangle ABD is congruent to triangle CDB by side, side, side. And that's all you had to do for number 4. Number 4 was a very straightforward, very cute little proof if you wanted it to be. If you didn't want it to be, you could unpack the whole parallel lines, you could get angles, you could prove this by side, 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 by angle, side, angle, by angle, angle, side, or side, angle, angle. You could do a whole bunch of things with this. No HL. Don't do HL. There is no right angle in this, so be very careful. All right, let's take a look at number 5. Number 5, do our statement reason chart. And we've got a whole bunch of different triangles. We want ADC, so ADC is over here, and EDB. EDB is right there. Okay. So first thing, ABEC is a rhombus. That's a given. Now, we could do, it's a rhombus, which means 2 pairs of opposite sides are congruent because it's a parallelogram, because a rhombus is a type of parallelogram. There's a whole bunch of different things that we could do. What I want to do is use the fact that it's a parallelogram, but not use the 2 pairs of opposite sides. I could do the 2 pairs of opposite sides. That would get me these 2 sides. Or we could do the fact that a rhombus has all congruent sides. In fact, let's do that. Nope, I lied. I don't want to do the rhombuses all congruent sides. You can. Fine. Rhombus has 4 congruent sides. That means this side, this side, this side, and this side are all congruent, but we really only care about AC being congruent to BE. All right. We take a look at the rhombus. So Rhombus, definition of rhombus, basically. First thing we have to know about rhombuses is four sides are congruent. Diagonals bisect each other. Diagonals bisect angles. But we don't have, like if we had this triangle and this triangle, that would help because the diagonal would be bisecting this angle up here. And that would give us something. But that's not helpful here. So at some point, we can start with the rhombus stuff. But what's really good about a rhombus is the fact that a rhombus is a type of parallelogram. If we look at the box that says rhombus, the first thing that it says is parallelogram. It has everything a parallelogram has. So, rhombus is a para, and a para. Okay, now we can do parallel sides. Yeah, we could do parallel sides. That would give us, you want to do that, Squirrel? No, you don't want to do that? I want to do that. Well, you could do parallel sides. You could do opposite angles, but in this case, that wouldn't help us because the angles are all chopped into pieces. You could do, what else? No, we could not use the consecutive angle sum to 180. That's just silly, Squirrel. That only helps us with maze problems. We could do bisecting diagonals. Diagonals bisect each other. You like that one? Okay, Squirrel has voted. And a parallelogram has diagonals bisect each other. Now, if you notice, I've written this slightly differently than I have before. That's okay. Very frequently, particularly on the Regents, when you're doing these advanced proofs, it's going to be hard for you to remember exactly how to write these. The key is to get the gist of it, to say, okay, this is what I'm doing. The proof is basically explaining your thought process. So, if diagonals bisect each other, that means AE and BC bisect each other. Yes, Squirrel, because I said bisect, the next thing I need to do is def of bisect. So if we do the definition of bisect, AE being bisected means it's now split into two pieces. That would be AD equals DE. And BC being bisected means CD equals DB. And then we've got definition of bisect, so that's good for both of them. And we can do side, side, side for the two triangles. You could do that. I've had people do the definition of, do these two and then the vertical angles. A lot of you, when you started coloring, automatically saw those vertical angles and was like, vertical angles, at least I got a pair of angles. That's great. You can go that way. At which point you can do that instead of this one. So you can say measure angle ADC equals BDE equals 90 degrees because of vertical angles. And then you'd get side angle side. That would work just as well. Problems for 4 and 5 would be there are so many different ways to prove these. So many different ways. You can do it any way you want. It's not like other proofs where you can only do it by side, 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 or you can only do it by angle, side, angle. You have to come up with one of those and fill in the reasons to prove that. You've got so many different givens when it says parallelogram or when it says rhombus that you can prove these triangles any way you want. It's just a matter of which way do you want to prove it. And the way you want to prove it might be different than the way Squirrel wants to prove it. And that's okay. All right, let's take a look at number 6. Number 6, we got a nice statement reason chart. We need to prove, and notice we've got angles. So when I want to prove certain angles, we're going to bubble those. We're not going to mark those. ACD. So ACD is this big angle right there. I want to prove that that bubble and angle BDC. BDC, that's this angle right there. So I want to prove that those two angles are congruent. At which point I'm thinking maybe this pink triangle right there and this blue triangle over there maybe. That seems like a good idea, but let's take a look at our givens. Let's take a look at the givens first. AD equals BC. So AD equals BC. Okay, yeah, we've got those lines crossing right there. So I want to go with this right here, this pink triangle here. We got overlapping triangles, Squirrel. Overlapping triangles. Always when we have overlapping triangles, we have to draw that out. So our goal would be to get that this C is important, and our given just gave us AD. And then the blue is right here. Blue triangle. That doesn't look like the blue triangle. That's better. Okay. C, D, B. Our mission is to prove that C is the same as D, and we've been given the hypotenuse. That's very exciting. We might be going hypotenuse-like if possible. Maybe, maybe not. We're not sure. Although considering we don't have the angle, highly doubtful that we can use that because that angle needs to be a right angle, and we need to know it's a right angle in order to use HL. If we don't know it's a right angle, can't use HL, even though it looks like a right angle. AC equals BD. Okay, AC equals BD, given. And this is one of my favorites. When we've got overlapping triangles like this, pay very close attention because overlapping triangles will frequently give us reflexive sides or reflexive angles. In this case, CD is actually a reflexive side. This CD is exactly the same as this CD. CD equals CD by reflexive. So that means that my two triangles are congruent by side, side, side. I was definitely on a side, side, side thing for this, apparently. Okay, ACD. Once again, be very careful when you're labeling these triangles. I started at the top with the pointy one. So A, which means B has to be where I start, went to the golden and then around. Went to the golden and then around. So BDC. Okay, now that I have my two triangles congruent, I can say measure angle ACD is congruent to measure angle, or is equal to, measure angle BDC, because corresponding parts in congruent triangles are congruent. Woot! And that is how we do number 6. Any questions on number 6? Because number 6 can be a little bit dicey, particularly with those overlapping triangles that we didn't know were overlapping, that we didn't even know that they were triangles because they gave us just random angles. Make sure to message me if you have questions. Okay. Since Squirrel has no questions, we'll go on to number 7. Number 7. Okay. This is going to be the most complicated one because it's the last one and because I'm evil. CEG. CEG is this guy down there. Now, if you notice, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got at least 10 triangles in this sucker. So be very careful when you get something that looks this dangerous. So CEG is this guy, and DEG is that guy. So that's our mission, to get those 2 triangles. Now let's take a look at where our givens are. First given, AE equals BE given. AE equals BE given. And that is not in my pink or my blue triangles. Awesome. Love that. Don't actually love that. Measure angle CAE equals measure angle DBE given. So CAE is up here. It's at A going towards C and E, and DBE at B going towards D and E is up there. Okay, so that's our second given. Third given, CG equals DG given. Okay, finally something that's actually in the 2 triangles that we want. That's exciting. Not helpful right now, but exciting. Many of you have also seen this guy right here. We've got a reflexive EG equals EG by reflexive. So these 2, very helpful in our pink and our blue triangles. But these 2, not so much, not helpful at all. But they are helpful if I add in some triangles, like if my pink triangle had a green triangle up there, and my purple triangle is right there on top of my blue triangle. We almost have the green and the purple triangle. Green and the purple triangle were super close. The pink and the blue, we've got 2 pairs of sides, but we have nothing else that we can't get angles, we can't get the other side. So we're going to have to prove the green and the purple first. And several of you are looking at the green and the purple and seeing vertical angles, which is awesome. So let's get those vertical angles. So that's going to be measure angle AEC and measure angle BED. And that's going to be vertical angles are congruent. Okay, so we got vertical angles are congruent. That will help us prove the pink and the purple triangles. I can say that the the green and the purple triangles. The green and the purple triangles are now congruent by angle, side, angle. So I can do AEC is congruent to triangle BED by angle, side, angle. That is because, notice, I'm not using these 2. These 2 are for my pink and my blue triangles. So I could move them down here. The 2 givens and the vertical angles, the first 2 givens and the vertical angles, prove my green and my purple triangles. So I've now proven my green and my purple triangles. I'm going to use my next given and a reflexive for the pink and the blue triangles. So these can go up here with the regular givens, or they can go down here with actually proving the pink and the blue triangles. It's up to you. I'm going to leave them where they are. But just know that those guys can float around sometimes, depending on if you noticed after this step and said, hey, wait, I can prove two triangles congruent right now. Let's do that right now. You didn't have to go on and do the given and the reflexive. You could circle back to that after you've proven the two triangles congruent. So you've got the green and the purple triangles congruent. We need to do something useful with the green and the purple triangles. And something useful with the green and the purple triangles would be probably this side right here and this side right here. This side and this side we know are congruent because they're sides in the green and the purple triangles. So we can use those sides in the green and the purple triangles to prove the pink and the blue triangles are congruent. So CE is equal to ED by corresponding parts. Incongruent triangles are congruent. At which point I've got the given, the reflexive, and this guy right here from CPCTC helping to prove that the pink and the blue triangles are congruent by side, side, side. So triangle CEG is congruent to triangle DEG by side, side, side. And if you've noticed, yes indeed, I have proved pretty much all of the triangles on this page by side, side, side. Just for fun, because I was bored. And this quarantine's starting to get to me. It's rough. So yes, that is how we do the back of practice 2. I want you to do the front of practice 2. Make sure that all of practice 2 is completely done. And tomorrow we are going to go on to proving parallel. So if you notice, now we have to prove the lines are parallel. We don't have the lines are parallel. We need to prove the lines are parallel. And guess what? We're going to be using a whole bunch of strategies. It's going to be gorgeous. All right. Also, just a reminder, remember, take that quiz if you haven't taken that quiz, and watch out tomorrow as I tell you what I want you to do for the labs for this week. Also, this is break week right here, so I will not be posting videos next week. Next week, I will not be posting videos, but of course you will have your break packet because I'm evil and cruel and despicable. So we'll talk more about the break packet a little while later too. Also, it's Spirit Week, so definitely take a look at my outfits. I am Spirit Queen. I am the reigning Spirit Queen, and I must uphold my title and do it justice. So, I shall see you all eventually, hopefully. Have a wonderful day. Peace out.